next time in class. Everyone have a good break. I know I will.
Wait, Dr. Broyer, I have a question.
What is it, Sanjani?
Can you go over SN1 reactions again?
Sanjani, you're the SI leader, and SN1 reactions happened 3 chapters ago.
Yes, but I forgot.
I'll explain it one more time. This is our starting SN1 molecule. SN1 stands for unimolecular nucleophilic substitution reaction. You see, Sanjani, this here bromine is a great leaving group. When the bromine leaves, it forms a carbocation in a polar protic solvent like ethanol. The carbocation is a secondary carbocation. It will rearrange into its more stable state as a tertiary carbocation. The valence electrons from the OH in the ethanol will then attack the carbocation and form this structure you see here. As you can see, there's a positive charge here on the oxygen atom, which is a no-no in organic chemistry, since we don't want a positive charge on an electronegative atom. Therefore, this O from the ethanol in the solvent will come and attack this hydrogen, leaving the electrons from the hydrogen to be transferred back to the oxygen atom in the structure, which leaves us with this structure. It's important to take into account the racemization of an SN1 reaction, but since this isn't a stereocenter, it need not be considered here. Since I am such an excellent professor, Sanjani, I've made you this chart. As you can see, in a polar protic solvent like ethanol, a secondary alkyl halide will undergo an SN1 or an E1 reaction, where it's important to take into account possible carbocation rearrangement as well as racemization of the product. In a tertiary alkyl halide, it can also undergo an SN1 or an E1 reaction. You see, I haven't listed the primary or the methyl alkyl halides because those undergo SN2, which is not applicable to this problem. In a polar aprotic solvent, a secondary alkyl halide will also undergo an SN2. In a tertiary alkyl halide, we will undergo an SN1 or E1 reaction, but we will require some heat. I've also made you a second table. Here are some examples of polar protic solvents, such as our friend H2O, our friend methanol, and our really good friend ethanol. And here we have our polar aprotic solvents, such as acetone, DMF, iodide, thiol, and the cyanide ion.
Oh yeah, I remember now. Thanks.
You're welcome, Sanjani. Have a good break.
Wait, what about an E1 reaction?
Are you really gonna make me explain another reaction? I just want to go home. All right, Sanjani. Now I've drawn for you an E1 reaction mechanism. As you can see, an E1 reaction is favored over SN1 in high temperatures. So here we have our tertiary alkyl halide. It goes through a transition state. Since bromine is a great leaving group, it forms a carbocation on the tertiary carbon. There's no carbocation switch because this carbocation is pretty comfortable where it is. And as you can see, this bromine has formed a little ion floating around in the solution. Next, the electrons from the hydrogen being taken by the water molecule transfer to form a double bond between the carbons. Here's our ending molecule. It's important to note that this is a beta carbon and this is a beta hydrogen. And in E1 reaction, the hydrogen from the carbon that is next door to the carbocation gets taken away and its electrons are moved to form a double bond.
Oh yeah, I remember now. Will this be on the final?
Yes, it will be on the final.